Hey there guys, welcome to the video. My name is Pushpinder Gill, and in this video we are going to be talking about fractions, and this video is specially made for students who are actually going to write the new SAT, and this video is actually going to be it's actually made just for the SAT students, so it might sound a little elementary for graduates. So I would actually recommend only students who are actually going to write the SAT exam should watch those videos, should watch this video. So let's go ahead and get started, guys. Right. So first of all, what are fractions? Before I go to even addition or subtractions. So fractions are nothing but numbers that you denote in P over Q form. So anything denoted in P over Q form is actually a fraction. Now fraction. So let's say, for example, half is a fraction, right? 1/3 is a fraction. 1/4 is a fraction. 5/6 is a fraction. So just that the value of Q should not be 0. That is something which is very, very important, because anything over 0 will actually be undefined. You can't actually define it, or it's infinite, right? And Q should not be equal to 1, because if Q is equal to 1, then you know what, you should not treat it as a fraction. You should treat it as a number itself. Fine. So I hope you're getting this point here, guys, that what is a fraction? A fraction is always of a P by Q form. Now there are some operations in fractions. Now usually students, even though they are allowed a calculator, they have to do some elementary operations and fractions by themselves, and it's always faster than actually punching those numbers inside the calculator. So there are few operations, and I'm going to show you how to actually go ahead and do those operations on fraction. Now the first thing is addition and subtraction. Now unlike numbers, like suppose you want to do 3 minus 2, you'll just do a 1, right? So that's pretty easy. But let's suppose I want to do 1/2 plus 1/3. Now you can't just call it, you can't add the top numbers and you can't add this, the denominator numbers. You can't do that, right? This is something which this is not how the fractions work. Now just to let you know, if you have a fraction P over Q, the top part of the fraction is called a numerator. So that I'll be talking about numerators and denominators in the whole video. So the top part is called a numerator, and the bottom part, it's called a denominator. Fine, just to let you know that. So you can't just add the numerators, or you can't just add the denominators and just get the fraction. There is a way in which you're supposed to add or subtract fractions. Now, the only way you can add or subtract fractions if the denominator is same, right? If the denominator is same, then only you can add fractions or subtract fractions. Let's suppose 2 over 3 plus 5 over 3. So that would just be 5 plus 2, 7 over 3, right? In case you can only add or subtract fractions when denominators are same. For example, 5 over 4 minus 3 over 4. So that is going to be 5 minus 3 over 4, which is going to be 2 over 4. But what if the denominator is not same? I mean, what if the denominator is not same? Then what are you going to do is, you're going to make the denominator same. Now, how do you make the denominator same? Well, what you can do is, so let's suppose, for example, if I say that you have this fraction, that fraction is 1 over 3 plus 2 over 9, right? Now, how do you make these denominators same? So you look at the smaller fraction here and look at the denominator. How can I make 3 to be 9? Well, that's something that I can do if I multiply this 3 by 3. Okay, but I've actually changed this fraction, right? I don't want to change this fraction. I want to keep 1/3 as 1/3. So what you can do is, if you multiply by 3 here, you can actually multiply by 3 here as well, and this will not change this fraction. I mean, this is literally the same fraction itself, but it's transformed into 3/9 plus 2/9, which is actually equal to 5/9. Let's say, for example, if I just use an example, let's say we have 2 over 3 plus 6 over 5. Let's suppose we want to do that. 2 over 3 plus 6 over 5. Now, as you can see that the denominators are different. Now, how can I make 3, 5 and 5, 3? There's no way I can actually make 3 5 or 5 3 because they're not multiples of each other. They're just distinct prime numbers. So what I can do here is I can multiply this by 5 and multiply this by 5. I can multiply this by 3 and multiply this by 3. Fine. So this is what I can do. So that will actually become 10 over 15 plus 18 over 15. And then I can just add them up. That is 10 plus 18 over 15, which is actually equal to 28 over 15. Fine. Now that is a way of doing this. Even for subtraction, you're supposed to do this. But since you're allowed a calculator in the test, you can actually go ahead and use a calculator if you really feel that you're not strong in that. However, I would recommend you to go ahead and practice on it. Practice a lot so that you actually become good in this, because this you might be required to do this using variables as well. Let's suppose you want to do x over y plus p over q. Then what you're going to do? Then you have to multiply this by q and multiply this by q and multiply this by y and multiply this by y. By the way, a dot means multiply. Then you have xq plus py divided by qy. Fine. So this is how you actually get this from here. So I hope you're understanding my point here, guys, because you need to know this, because your calculator won't be able to do this at all. Your calculator will be able to do this, that's fine, but won't be able to do this. So you have to make sure that you don't rely completely on your calculator. So here are some points that I would like to summarize here. Points are, first thing is, they can only add or you can only subtract if the denominator is same. So if the denominator is not same, you can't add or subtract. If the denominator is not same, you can make the denominator same by multiplying by a number so that the denominator becomes same. Now this is more of an art kind of thing. So let's suppose if I say 1 over 3 plus let's suppose 5 over 12. So you don't need to multiply this by 3 and multiply this by 12. You know that 3 times 4 actually is 12. So you can just multiply by 4 here and multiply by 4 here. You'll have 4 over 12 plus 5 over 12, and then you'll have answer as 9 over 12. Fine. So I hope you're getting my point here, guys. So this is about addition and subtraction. Let's move on to the next part, which is multiplication and division of fractions. Now there are few things which are a little tricky here. We'll move on to that. Now, how do you multiply fractions? Now let's suppose if I have fraction 1 over 2 times 5 over 6. So if I want to multiply the fractions, it's very, very simple. It's just that this multiplication will actually be just this line will actually be for all the fractions, and all the denominators will get multiplied and all the numerators will get multiplied, and you'll just have 5 over 12. So let's suppose I want to multiply 3 over 8 into 7 over 2. So 7 times 3 is 21, 8 times 2 is 16. So that is the answer. So in some cases, let's suppose if I want to do multiply 3 over 8 into 2 over 7. So there are two ways in which you can do this. One way is you just multiply the numerators and multiply the denominators. Or another way is you can first go ahead and factorize the fractions. So you can see that 2 times 4 is 8. So this is what I will personally recommend. 2 times 4 is 8. So this actually becomes 3 over 7 times 4, that is 28. And even if you kind of divide both the fractions by 2, you will get 3 over 28. If you divide the whole fraction by 2, if you divide by 2 here and you divide by 2 here, you will actually get 3 over 28. So this is a more efficient way of doing this and a better fraction, because you get a reduced fraction out of this. You don't always have to use your calculator to actually get the multiplications. Let's suppose you get this 3 over 9 into 9 over 3 into 7 over 5 into 5 over 7 into 6 over 3 into 3 over 6. So let's suppose you get this. So you don't have to actually multiply all the top ones and multiply all the bottom denominators and then get the result. You can say this 3 goes with this 3, this 9 gets cut by this 9, this 7 gets cut by this 7, this 5 gets cut by 5, 3, 3, 6, 6, and the answer is 1. Right? So this was more of an extreme thing that I was doing, but as you should actually do a lot of practice in solving these kind of problems, in working fractions in this kind of way. Now, the next thing is division. Now, division is very, very important. How? It's a little tricky, I would say. So let's suppose if I say I want to divide 2 by 3 with 5 by 6. So what's happening here? What does this mean? This means that 2 by 3 is actually divided by 5 by 6. This is what is happening. So imagine what will happen to this 5 by 6. This 5 by 6, when it goes there, this 6 will actually go at the top. So you will have 2 by 3 into 6 by 5. So what has happened to this 5 by 6? This 5 by 6 actually became 6 by 5. So whenever you divide two fractions, so a by b divided by c by d will actually become a by b into, this is going to reverse itself, that is d by c. So this is going to become the reciprocal of that. So I hope you're understanding my point over here, guys. That is very, very important. So I'm just going to summarize what I just said here for division. For division is that, let's suppose if you have 8 by 9 divided by 7 by 6, so that is equal to 8 by 9 into 6 by 7, and then you can just go ahead and calculate. So this goes at 3 times 2 and 3 times 3, so that is 16 over 21. Fine. Now there are two more things. So whenever you get something like this is nothing like a by b, the whole thing divided by c by d. There is one more way in which you can actually do division, right? So that's way. So that is equal to a by b into d by c, right? Because this d actually goes up there. Now there are two things that I want to talk about. Let's suppose a is divided by b by c, and a by b is divided by c. Now this is something that you represent as a is actually divided by b by c, and this is something that you represent as a by b is actually divided by c. Now these are two different things. These are not the same things, even though the representation looks almost the same, but these are two different things, because in this what is going to happen? You're going to get a into c over b, right? So this c is actually going at the top. It's going to go at the top. And in here, it's going to be equal to a by b into 1 over c, because this is going to reciprocate itself. So this is ac over b, and this is nothing but a over bc. Are you able to see the difference here? There's a difference. That means this denotation and this denotation is different. Whenever I say a divided by b by c, the c goes up there. So that's ac over b. And whenever I say a by b is divided by c, the b goes down. That is actually equal to a over bc. So that is the difference. Most of the students get confused in that. So make sure that you know, where is this division sign coming? Where is this division sign coming? So this division sign is usually the bigger line, right, than the smaller line. So these two things are completely different. So I hope you understood this part here, guys. I hope this was clear. Moving forward to the next part, that is simplifying fractions. Now, I've actually talked about simplifying fractions in this video before, but here I'll actually talk about it formally. So let's suppose if you have a fraction 3 over 9. Now this fraction is something which can be further simplified, because as you can see that a 9 consists of two 3's, right? And you can actually eliminate this 3 and you can say 1 over 3. Fine. So this is what you can do. So let's suppose if you have 5 over 125, right? So now you know that 125 consists of 3 5's, right? So you can get rid of this 5 and you can just have 1 over 25. So this is what we call simplifying fractions. You should know how to simplify fractions. Let's say if I have, for example, 12 over 16. A 12 is made up of a 4 and a 3, and a 16 is made up of a 4 and a 4. So this 4 and 4 goes, and I'm left with just 3 over 4. So I hope this is fine here, guys. So you should actually work out a lot in simplifying fractions. I think you must be doing that since high school, and to actually understand about simplifying fractions, you should know the divisibility rules. Now, what are divisibility rules? The divisibility rules are the rules that tells you that whether this number, let's suppose any number, let's say 538, is divisible by some numbers or not. So I'm going to start the divisibility rule of 2. How do you know whether a number is divisible by 2? Well, that's easy. If the last digit of the number, it's 0, 2, 4, 6 or 8, that means that the number is divisible by 2. You can pick up any number. Let's say 56 is divisible by 2. It has a 6 at the end. 78, it's divisible by 2 because it has an 8 at the end. Even 538 is divisible by 2 because it has an 8 at the end. So any number whose last digit is 0, 2, 4, 6 or 8 is going to be divisible by 2. If the last digit is not 0, 2, 4, 6, 8, it is not going to be divisible by 2. Then the next thing is divisible by 3. If the sum of digits is divisible by 3, then the number is going to be divisible by 3. Let's say, for example, 21. What is 2 plus 1? 3. That means 21 is divisible by 3. Let's say 69. What is 6 plus 9? 15. What is 1 plus 5? 6. 6 divisible by 3? Yes. That means 69 is divisible by 3. Let's talk about 538. What is 5 plus 3 plus 8? That is 16. 1 plus 6, 7. Is 7 divisible by 3? No. 538 is not going to be divisible by 3. So the sum of the digits has to be divisible by 3. Then only our numbers are actually going to be divisible by 3. Let's talk about 4. For 4, the last two digits has to be divisible by 4. So the last two digits have to be divisible by 4, then the number would be divisible by 4. Let's say, for example, 40 is divisible by 4. If 40 is divisible by 4, then 140 would be divisible by 4, 8140 would be divisible by 4. Pretty much any number ending with 40 will be divisible by 4. If 56 is divisible by 4, then 356 would be, then 536 would be, then 356 would be. So if the last two digits are divisible by 4, all the numbers are divisible by 4. Let's talk about divisible by 5. The last digit has to be either 0 or 5. If the last digit is 0, let's say 80 or 85, the number is divisible by 5. But if the last digit is not 0 or 5, the number is not divisible by 5. So I hope that's clear to you guys. It's very, very important. These are the weapons that you would be taking with you. You would be using that not only in your SAT, but throughout your graduate school or your undergrad school, till how long you go to school, right? Even past that. Now, the next number is 6. Now, 6 has to follow the rule of the 2. That means the last digit has to be 0, 2, 4, 6, 8. And it has to follow the rule of 3 as well. That means the sum of digits has to be divisible by 3. For example, number 36 has a 6 at the end and 3 plus 6 is 9. That means number 36 is divisible by 6. Number 54 has a 4 at the end and 5 plus 4 is 9. That means the number is divisible by 9. I'm going to do two more. That is number 8. For number 8, the last 3 digits should be divisible by 8, right? So the last 3 digits should be divisible by 8. Then the number is going to be divisible by 8. And for number 9, the sum of digits should be divisible by 9. So what it should be? The sum of digits should be divisible by 9. Let's say, for example, if you take the table of 9, 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36, 9 times 5 is 45 and so on. Just add the numbers up, see what you get. You always get a 9, right? You always get a 9. So the sum of digits are divisible by 9. That's why the numbers are divisible by 9. Fine. So these are the rules that I want you to know. The rule of 2, the rule of 3, rule of 4, 5, 6, 8, and 9. And then you can actually make out a lot of things from here. I don't want to go to the rule of 11 because I believe it will not be the part of SAT. So rule of 2 says 0, 2, 4, 6, 8 as the last digit. Rule of 3 says the sum of digits should be divisible by 3. Rule of 4 says that the last 2 digits should be divisible by 4. Rule of 5 says that the last digit should be 0 or 5. Rule of 6 says that it should follow the rule of 2 and the rule of 3. And rule of 8 says that the last 3 digits should be divisible by 8. And rule of 9 says that the sum of digits should be divisible by 9. So this is what we call about the divisibility rule. So that will actually help you in simplifying fractions to know that this number is divisible by that number or not. Especially in the non-calculator section, this would be extremely useful for you guys. So let's say, for example, we want to break this up. Now, if you want to break this up, I'm actually going to write that down here. 135,492 divided by 428,376. So let's say this is actually in our calculator, non-calculator section, and you won't get this question in your calculator section, but I've exaggerated it a little bit. So 135,492. So as you can see that the last two digits are divisible by 4. Last two digits are divisible by 4. So this number is actually going to be divisible by 4. Okay, so this number is going to be divisible by 4. Another way to check is divisible by 8, right? Well, I'm not going to take that shot. So I'm actually going to cut this by 4. I'm going to put that. I'm not going to waste your time. I'm just going to do that quickly. So that is 33873 divided by 428,376 divided by 4. It's a big number, 107094. So see, we were able to actually hit it with our first shot that this number is actually divisible by 4. Now, this number is not divisible by 4 now, but we can actually go ahead and check it whether it's divisible by 3 or divisible by 9 by checking the sum of digits. So if we add the sum of digits, there's a 3 here, there's a 3 here, there's a 3 here. 8 plus 7 is 15. So 3 plus 3 is 9, 9 plus 3 is 12, 12 plus 15, it's 27. Well, that is divisible by 3 and divisible by 9 also. And if I add this number up, 7 plus 1 is 8, 8 plus 4 is 12, and 12 plus 9 is 21. So that means this is divisible by 3, but not divisible by 9. So this is how you go further. This is how you actually simplify a fraction, right? I want to do that completely, but I wanted to show you that this is how it works. You don't have to get intimidated by big numbers. You can actually go ahead and perform the process of elimination, and now you know that this number is divisible by 3 and divisible by 9, but this number is only divisible by 3 because if you add the numbers up, like 1 plus 0 plus 7 plus 0 plus 9 plus 4, it actually comes down to be 21. Now 21 is divisible by 3 but not divisible by 9. And if you add these numbers up, that is 3 plus 3 plus 8 plus 7 plus 3, that actually comes down to be 27. This is divisible by 3 and divisible by 9. Right? So that's there. So hope you're able to understand my point here. Moving on, just gonna skip that. Okay, so let's use our divisibility rules here. So this question here says that which of the following numbers is divisible by 5 and 9? So here's what I'm actually going to show you. My first technique. My first technique is process of elimination. Don't try to go for the right answer. Try to eliminate the wrong answer. So it has to be divisible by 5. So the last digit should either be 0 or 5. And as we can see here, all the numbers have the last digit to be 0 or 5. Fine. Let's check it. Which of the following numbers is divisible by 9? We're going to add the numbers up. 4 plus 2 is 6. 6 plus 2 is 8. 8 plus 3 is 11. And 11 plus 5 is 16. So this is not divisible by 9. 3 plus 4 is 7. 7 plus 3 is 10. 10 plus 7 is 17. Not divisible. 4 plus 6 is 10. 5 plus 5 is 10. That's 20. Not divisible. 7 plus 3 is 10. 8 plus 4 is 12. And a 5. So that is 10 plus 12 plus 5. That is actually equal to 27. This number is divisible by 9. Hence, it is my answer. So you don't have to literally go ahead and check whether this number is divisible by 9 or not. You can just go ahead and add the numbers up, and you don't need to test this because you've already found your answer. You don't need to test this at all. So hope this is fine, guys. I hope you're able to understand this point here. Moving on. So this looks like a little tricky question. So this says that given that this number, the number is 8321p. In order for this number to be divisible by 3, 6, and 9, p must be. Okay, so 8 plus 3 plus 2 plus 1 plus p. That is actually going to be 12 plus 3 plus p, which is going to be 14 plus p. Now for it to be divisible by 9, it can either be 18 it has to be 18 though, because the sum has to be divisible by 9, and any number after 14 is 18, which is divisible by 9. So P has to be equal to 4, so that 14 plus 4 is actually equal to 18. So that means my answer is equal to 4. So hope you're understanding my point over here, guys. In this question, it was easy. The question was 8321P has to be divisible by 3, has to be divisible by 6, has to be divisible by 9. So the sum of digits has to be divisible by 9. So I added the digits. I got 14 plus P. So that means P has to be equal to 4, so that it actually turns out to be 18 and it's divisible by 9. So P is equal to 4. Fine. So I hope you're getting my point here, guys. I hope this is easy for you. Okay, so let's see this question. Looks like a difficult question. It says that n factorial means, so these kind of things you should know beforehand. I mean, n factorial just basically means 1 into 2 into 3 into 4 all the way till n. Fine. So he says 19 factorial is divisible by. So what is 19 factorial? 19 factorial is 1 into 2 into 3 into 4 all the way till 19. Now, does this have a 17 in it? Yes. Does this have a 54 in it? Well, you must be thinking no, but there is, because 54 is 18 times 3, and it has an 18 also, because 19 factorial is 1 into 2 into 3 into 4 till 18 and 19. So it has an 18 in it, it has a 3 in it, which means it has a 54 in it. There you go. Is it divisible by 10? Does it have, what is 100? 100 is 10 times 10. Well, you have a 10 in here. What about the other 10? Well, you have a 5 in here and you have a 2 in here. Well, that works out. Fine. And what about 39? 39 is 13 times 3, right? So there is a 13 here and there is a 3 here. So this also works out fine. So that means all of them are divisible. 19 factorial is divisible by all these numbers. It's divisible by 17, it's divisible by 54, it's divisible by 100, and it's divisible by 39. Well, if I say, is it divisible by 41? No, because 41 is a prime number. 41 cannot be broken down into numbers. So 41 will not be a part of this at all. Fine. Pretty easy question, but can get tricky if you don't pay attention. So I hope that's fine, guys. I hope this is clear. I hope you're able to understand my point here. Let's move forward. So thank you very much for watching this video, guys. This was the part 1 for fractions. In the coming videos, we are actually going to be talking about the mixed fractions, and we're also going to be talking about how to compare fractions. We're also going to be talking about how to solve the verbal problems in fraction. Right, so how do you solve the word problems, I would say, with fractions, right? So till then, guys, keep watching this video. Make sure that you give us your valuable like on this Facebook page, explore our website for more, and if you can give us your valuable feedback at support@perfectscores.org. So thank you very much for watching this video, guys. I'll see you in the next one.